So after sketching this problem, it may seem obvious that the shape is a square. However, when we're doing analytic geometry, as well as in math in general, a picture is not proof. You need to do the math and perform calculations in order to prove what type of quadrilateral this shape is. So first let's look at the lengths of the sides. So we have to do 4 different length calculations. So we'll write our formula 4 times, once for each segment. So side PQ, we're going to sub in 6 minus 1 squared and 5 minus 3 squared. 6 minus 1 is 5, 5 minus 3 is 2, 5 squared is 25, 2 squared is 4, 25 plus 4 is 29, so the length of side PQ is root 29. For side QR, we have 8 minus 6 plus 0 minus 5. 8 minus 6 is 2, 0 minus 5 is negative 5. Squaring, we get 4 plus 25. So the length of segment QR is root 29. For RS, 3 minus 8 and negative 2 minus 0. So we get negative 5 squared plus negative 2 squared. So we have the square root of 25 plus 4, which is again root 29. Finally, for side PS, 3 minus 1 plus negative 2 minus 3. We subtract 2 squared plus negative 5 squared, root of 4 plus 25. So again, that's the root of 29. So the sides are all the same length, so we need to check the slopes to decide if it's a square or a rhombus. So we'll write the slope formula 4 times and sub in. So y2 minus y1 is 5 minus 3, x2 minus x1 is 6 minus 1, giving us a slope of 2 over 5 for side PQ. For side QR, 0 minus 5 over 8 minus 6 gives us a slope of negative 5 over 2 for side QR. RS, negative 2 minus 0 over 3 minus 8 gives us a slope of negative 2 over negative 5, which is equal to 2 over 5 since negative divided by negative is positive. So the slope of RS is 2 over 5. Finally, the slope of PS, 2 minus 3 over 3 minus 1. So the slope of PS is negative 5 over 2. So opposite sides, PS and QR, have an equal slope of negative 5 over 2. And opposite sides, PQ and RS, also have equal slope, in this case 2 over 5. As well, the slopes of adjacent sides are negative reciprocals. Negative 5 over 2 is the negative reciprocal of 2 over 5. So therefore, since they meet at right angles, our shape is a square. So now we need to show that the midpoint of PR, that's this diagonal, lies on the line passing through the points Q and S. So to find the midpoint of PR, we use our formula, and we get 8 plus 1 and 0 plus 3. So 9 over 2 and 3 over 2 for our midpoint. Now we need to show that this lies on the line passing through QS. So we'll calculate the slope of QS, negative 2 minus 5 over 3 minus 6. So we get negative 7 over negative 3, or 7 over 3 for the slope of the line passing through QS. Now we can use our point slope formula for a line, and one of the points, either Q or S. So in this case, we'll use point Q. So we have y minus y1, which is 5, equals m, which is 7 over 3, times x minus x1, which is 6. So 7 over 3 times x is 7 over 3x, and 7 over 3 times negative 6 is negative 14, since 7 times 6 is 42, and 42 over 3 is 14. Adding 5 to both sides, we get an equation for line QS of 7 over 3x minus 9. So to show that the midpoint we calculated earlier is on this line, we need to think of the midpoint as the x and y values and do a left side, right side check of this line. So our midpoint, remember, is 9 over 2 and 3 over 2. So the left side of our equation becomes just 3 over 2 when we substitute in y. The right side of our equation, we substitute 9 over 2 for x, and then we multiply. 7 times 9 is 63. 3 times 2 is 6. Writing 9 with a common denominator, we get 54 over 6. 63 subtract 54 is 9, so our right side is 9 over 6, which reduces to 3 over 2. So therefore, since our left side and right side are equal, this midpoint satisfies the equation of the line through QS. So therefore, we could say that the midpoint of PR lies on the line that passes through QS. So now in this example, what type of quadrilateral is formed by joining the vertices A, B, C, and D as sketched here? Calculate the midpoints of the diagonals AC and BD and tell me what you notice.